Alright, let's take a look at what I think is the last problem. It's that or the next to the last in this problem set. Alright, so we have this motorboat that maintains a constant speed of 23 miles per hour relative to the water. So that means without a current, just in calm water, this boat can move at 23 miles per hour. Now, when it's in a river, say, that has a current, then that current's going to affect the speed of the boat relative to the shore, right? So this boat goes upstream to a certain point and then turns around and comes back. So it's a round trip situation. The distance that the boat travels upstream is the same distance that the boat travels downstream. And distance is rate times time. So we're interested in returning to the problem and determining if it gives us the rate when you're traveling upstream and if we can figure out the time that it travels upstream. When we go back to the problem, can we figure the rate that it's traveling downstream, and can we figure the time that it's traveling downstream? Well, it tells us the rates. No, it doesn't. It tells us the times. The boat traveled upstream, and it took 28 minutes. Downstream, it took 18 minutes. Well, that makes sense because when you're going downstream, the current is helping you move faster than the 23 miles per hour. That current is pushing you along, so you're going to travel the same distance in a less amount of time. When you're going upstream, the current is slowing you down, so it's going to take a longer length of time to travel that distance. So it makes sense that the time upstream is greater than the time downstream. Now we know that in calm water, let's see, what is it asking us? It's asking for the speed of the current, so let's let that be x. So we said that going downstream, the current is helping you move faster, so 23 plus x. When you're going upstream, it's making you go slower, 23 minus x, where x is the speed of the current. So let's tell people that. Yep, I lost the 18 there. Here, let's scoot this a little bit closer here. And our units is miles per hour. Alright, now although the 28 and the 18 is in minutes, we don't have to convert that to hours because the units on the left hand side are the same units on the right hand side. So any conversion that I would do to 28 would be the same conversion that I do to 18. So since it's an equation and you do the same thing, the left hand side, the same thing, the right hand side, we don't have to make that conversion from minutes to hours. Alright, so let's distribute. Now I don't have an idea of what 23 times 28 is. Other than it should be bigger than 400. 644. 23 times 18. That'll be closer. Yeah, I knew that would be closer to 400. And 18 times x. Alright. So let's take our 644 and subtract 414. 230. And let's take 28 plus 18. And that is 46. Let's take 230 and divide it by 46. 5. So, if we've done things correctly, the speed of the current is 5 miles per hour. And that's all it asked for. What's the speed of the current? 5 miles per hour. So you can see that at 5 miles per hour, when you're going downstream, you're moving at 28 miles per hour, and at 5 miles going upstream, you're moving at 18 miles per hour. All right, so I hope that helps.